All right, made this video to help you guys out with the dilations and scale factors Deltamath assignment. All right, so for the first one, what we're doing is we have a series of transformations, and one of those includes a dilation. And in this case, it's going to be a translation and a dilation. So keep that in mind. The title actually tells us, in this case, kind of what we're going to be doing. Now, what I'd like to do is I like to focus on the dilation first. Okay, so with the dilation, we want to figure out what's the change from the old shape to the new shape. All right, so what I'm going to do is take one side and make sure you match up the letters, right? So I want to go from the original A and B to the new AB because it might be in a different place. Okay, so make sure you're always paying attention to that. So now for the old shape, the length of AB is 1, 2, 3, 4, 5, 6 units. And for the new shape, it's 2 units. So what I'm going to do to find the scale factor is, let me make that a little neater, is I'm going to divide the new divided by the old in order to figure out the scale factor. So I basically take a new length or measurement and divide it by the corresponding old measurement, and then that will help me find that. So in other words, the new side is 2, the old side is 6. That should help me figure out the scale factor. So 2 over 6. Now I can't divide 6 into 2, so I would have reduced that. Divide them both by 2, and I get 1 over 3. Okay, so now I know my scale factor is going to be 1 over 3. And usually always your scale factor should be less than 1 if you're going to if the object is shrinking. Okay, let me bring me back up here. Okay, so here 1 over 3 is what I typed. And now remember we're doing a translation, right? So the question is how far is it moving? And in this case we're moving to the left. So how far left are we going? All right, well, I know we're going left because it's moving from this red object to the blue object. But how far? Let me just take a guess. I'm going to guess like 6. Okay, let's try that. All right, so it's going to shrink down to there. And you can see it got close, but it didn't quite match up. All right, so I noticed that I probably need to go 1, 2 more units. Okay, so let's try 8. So it shrinks it down. Now they're the same size. Now it matches up. So once it matches up, we're good. All right. So that's translation. So let's go to the next section. The next section, you're going to see reflections. Remember, reflections mean you're going to flip something, right? So still, again, we want to look at the shape and figure out the scale factor first. So let's start with that. Okay, so the scale factor, the side, let's start with CB, okay, or BC here, and it's 3. And then I want to make sure I go to the same side over here. And BC is right here. So for instance, again, follow follow which side you're going to, because let's say you chose C and D. Well, C, D is not on the top anymore. It flipped down here to the bottom. Okay. So here we're going to use BC and we're going 1, 2, 3. On the new shape, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's figure out a scale factor. Remember, on the new shape, 9. Old shape, 3. Now we can divide. Now we can divide 9 divided by 3, and that will equal 3. Okay, so here, let's go. We're going to put in the dilation of 3. And remember that we're flipping it now. And you can tell it's a flip or a reflection because I see that D, C, and D go down to the bottom here. So that means it kind of flipped down, right? So we got a reflection. And now it's going to ask you, did it flip over the y-axis or the x-axis? Well, if you think it's going to flip down this way, right? So you got to figure out, okay, which axis is it flipping over? Let's try the y. So I got the right size. Oh wait, it flipped over the y-axis. We wanted to go down, we didn't want to go this way. Okay, we wanted to come down, so we wanted to flip over the x-axis. Let's try that. It gets nice and big, same size, flips down. Now we got it to match up. Okay, great. Okay, so now next section. Now the next one is rotations. Okay, so with the rotation, okay, we still want to figure out the dilation scale factor, right? So let's start with the dilation again. And now if you get a problem like this, you might be like, well, it's kind of hard to figure out the length of that side because it's diagonal. So which one do I choose? Do I need to bring up Pythagorean theorem and figure out the length of this side? And then no. Okay. So remember that all the dimensions of the old shape to the new shape should be proportional. All right, and that's the word that we use for when we take one side to the other, right? But we don't always need a side. We could use a measurement in the middle. So if you think about it, from A to C, that same measurement should be should be proportional to AC here. Okay, sorry about the bell. All right, so our old shape is from A to C is 1, 2, 3, 4, 5, 6. And the new shape from A to C, and remember, careful which one you're using because, in this case, D to B is the same as A to C proportion-wise, but just want to be careful, with your shape. So from A to C here is 3. So 6 and 3. All right, so now, again, new shape is 3. Old shape is 6. And now we can divide both of these by 3. And we get 1 over 6 divided by 3 is 2. So 1/2. So the scale factor here is 1/2. All right, now remember we're doing a rotation. And you could tell it's a rotation because, one, if I just move it, it's not going to be quite matched up, right? D doesn't become C, right? And if I flip it, B should be like on the corner here. So it's neither of those. It's got to be a rotation. So it probably kind of rotate it this way, All right, so here notice that it only gives you one option for counterclockwise or clockwise, okay? So you have to use that to figure out how many degrees. Now, if we're going to go counterclockwise, you have to think. Counterclockwise would be in this direction, okay? So if we're going in this direction, so I use my little pen here. There we go. We're going to go this direction, right? All right, so now when I move to one quadrant, that's 90 degrees. Two quadrants, that's 180 degrees. Three quadrants, that's going to be 270 degrees. In other words, every quadrant you're moving 90, so you're adding up 93 times. Okay, so that's where that number comes from. All right. Okay, so let me erase all that now that we know where we're going. Okay, so now we're going to go 270 counterclockwise. Let's try that. Actually, let me just mess with it and see what happens when I choose 90. Because some of you guys might think, oh, I just have to go 90 degrees. Let's see what happens. It goes 90 degrees that direction. So that's why we need an additional 180. Okay, here we go. Straight out. Shrinks, looks good. Same size, and all the way around. Now we're matched up. Okay, so that is rotations. All right, next section. Okay, so now you're going to be looking at one shape and a new shape, and you need to figure out what sides correspond. And when I say correspond, that means if I'm looking at, let's say, this shape KN this shape here, let's say MO, right? MO is the same side on this larger shape, which is IJ. So those, because they're the same sides, even though the shape's bigger, that's called the corresponding side. The question is, which side in the figure on the right, this one, this shape, corresponds to segment KN. So which one corresponds to this one right here? Well, I go straight over to this shape, and that would be FG. Okay, the next question is, what's the scale factor? Now, to again figure out the scale factor, you need like a straight vertical measurement or horizontal. You don't want to try to find the diagonal. It's just, I mean, you could, but it's just, it's not more work than you need. All right, so I just need to figure out one measure. I could do like this side right here, GE. I could take a length from, let's say, H to G and then L to N. It's kind of whatever you want to do. All right, so I'm going to pick a side. Let's do NP and GE. All right, so I'm going to zoom in a little bit to measure this out. So 1, 2, 3, 1, 2, 3. So that's 6 for the shape on the left. And remember, we're going from the left to the right. Okay, so all these shapes always go from left to right when you're figuring out which one's the new and which one's the old. Okay, so here, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so that was 12. All right, so same thing like before. New shape's 12. Old shape's 3. So it means we divide by 3, our scale factor is 4. Oops, I apologize. You guys probably like, wait, what are you doing, Mr. Osborne? Sorry, that was not a 3 down there. That was 6. I'm like, what is going on? So sorry, it was a 2. Oops. So the scale factor is 2. So that's good. It only gives you a limited option. So if you make that same mistake, then you'll know. All right. All right. Let's see if I'm right. All right. I got it right. Cool. All right. So here you can see they showed you how to do it. So they took the 6 units here, the 12 units here. They set it up a little bit differently. You can use this method and figure out the K factor is what they call it, which is basically your scale factor. Or do it the way I did it and set up your new shape over your old shape. Okay, both ways work. All right, let's go to the last section here. It looks like this is just basically pretty much the same thing. Okay, so this is just another section of the same problems. Okay, and that's it.